In computer hardware right now, there's a surprising secret or mystery. If you look at workstations or consumer CPUs, the number of cores is staying relatively flat, but there's this explosion that you see in data center CPUs. And that's very surprising, and we're going to look at what that means. And there's also an explosion in the number of virtual CPUs in the cloud and the number of threads that are available. And if we jump in and look at the hardware, we can see in 2017, we've got 32 cores, 64 threads here. And then over time, as we're looking at the top EPYC chips over time, you just see this explosion in cores, threads, virtual CPUs. And moving into this new thing, and if we look at the parts here, this is the packaging for the processor. If we zoom in on the SoC, this is a chiplet where we've got a ton of cores. Just one of these is what used to be a computer in 2001. If we zoom in, these are governed by core complexes, CPU complexes, and then inside we've got a single CPU core that's at 3 nanometer. The scale is decreasing dramatically, and there's explosion of these chiplets and explosion of these cores. And you can see there's still room to grow here. So they're sort of evolving in a shocking new way that's very surprising, and the fidelity is increasing a lot. Now, if we look at the data center, at the same time we've modeled, say you're a cloud provider, you're giving 100,000 vCPUs, you can see there's this dramatic decrease over time in the footprint of your data center. And where's the data center going? Well, it's going into the chip, into the processor. So what we're seeing is the data center is becoming a processor, is becoming a CPU or a computer, and the computer is becoming the data center. So there's this unusual flip in terms of technology that's occurring. And we're jumping from the meter scale to, down to 10 millimeters, down to we're getting close to a single millimeter or sub-millimeter scale for a core. And as a software programmer, performance programmer, getting a 40% gain in performance, you're something you're just so excited about. Here, the increase in scale, the decrease in latency, decrease in scale, and the latency reduction is enormous. It's orders of magnitude, hundreds of thousands of times faster as you decrease. And so when you think about what does this mean? The computer becomes the data center becomes a computer. Well, the obvious thing is data center workloads are going to become more part of normal computing. So transactions like loading cache data, loading websites, this is the main thing that data centers do. But there's this growth of these new kind of workflows, these analytic workflows where these deep dependency trees and relationships are analyzed very quickly, or very complex things. You model the weather or model some giant complex system, and you're able to pull out a result very quickly. And that's called HPC computing, high performance computing. So in dashboards, you can think, just to pick a case study, we're going to move to modeling entire countries, cities, companies, and those are going to be able to use these new kind of workflows. So you're going to be able to jump in and ask interactive questions. Dashboards tend to revolve around cache data at the moment. So people pre-compute everything in the dashboard's just giving you a view on pre-computed data. But this new world where the data center is in the workstation, you're going to work with live data, and you're going to figure out everything at this very deep level as you maneuver and ask questions. And I think that's going to be across the board. So not just in dashboards, and just across the software domain. We see a lot of talk in AI, and you can see it in dashboards, but it's going to be across all software this is going to happen. Now, if we look at the global trend of this, the prediction is that this is going to trickle down, that the transformation of the data center is going to move to the point where the data center is on a phone or a watch or a computer or a workstation. And what that's going to mean is the price of cloud is going to come down dramatically. And the cloud providers are going to offer more. They're going to offer more virtual CPUs because in the last 7 years, the density has increased 8x. And in that scenario, there's going to be a lot of innovators. A lot of innovators in terms of startups are going to be giving new offerings in that space. As we continue in containers, you're going to want to get out of the meter scale. You're not going to want to be at 10 or 100 meters. You're going to want to be within the sub-millimeter scale. So the way containers work is probably going to evolve. Right now, you could do a lot of access to hardware in a single container and do work that way, but I think we're going to see that space evolve a lot. In terms of workloads, we're going to see this growth of data center thinking, analytic workloads, and HPC workloads in normal software. And this is going to be a new way of programming, a new way of thinking for software developers. In workstations, they're stuck a little bit because games tend to focus on single core performance. But game coders are amazing coders, and I think we're going to get over that hump, and games are going to take advantage of all this. There's going to be a lift in the workstation, and they're going to start to look more like data centers. And software is going to focus on this real-time environment where everything is changing. You can ask questions, and there's going to be this emphasis on threading and compute to figure out something very complicated in milliseconds. Thank you very much.